Welcome everybody to today's lecture. Today we're going to be starting our conversation, our discussion about reading and writing from files. So this will be a multi-part series that will talk about that. In the book then, this will be corresponding to the content in Chapter 11, and we're not covering everything in Chapter 11. So if you have your textbook, 11.1 through 11.5 it looks like. 11.6 talks about random access files, and we're not going to talk about random access files. So we'll just be reading and writing to sequential access files. We're going to start off then taking a look at the lab, and then we'll talk in this lecture, we'll just go through reading from a file. So I'll introduce that, we'll look at some code, and then we'll wrap it up and say for the next lecture actually writing to a file. Once we've figured out how to read from a file, writing to a file is almost the same exact thing. The only thing we change or add is a different function. We add a way to write to the file instead of reading. Also, here, when we're going to look at Lab 7, in your book, I'm going to provide you some sample code, but in your book, if you look at about page 428, it's going to depend a little bit on the version that you have. That's going to be a program very similar to what we're going to do for the lab. Okay, so if you don't want too much of a hint, then don't look at it. But if you feel like you're getting stuck, you can use that for a pretty good idea on how to get through the lab, as well as the sample code I provide. Okay, so what is the lab then? For Lab 7, one of the things I want to point out, and I know this becomes a little bit more of a challenge when you're working online, but you can work in groups on this and submit identical files. So if you've already been working with other people through the online course, maybe you've met them through the class list or through other courses that you've taken, feel free to team up in groups. Make sure though, I need a submission from everybody. So everybody has to still submit their code through the Dropbox, and all in that source code, you're just going to be submitting one C file. I need your group name, your team name, not your team name, I'm sorry, but every group member in the comments in the header of that file. So that way when I look at your submission, if I see two submissions that are identical, in those comments I can see that, well, you guys work together. So it's very obvious, and that'll help me out quite a bit. If you don't have anyone you're working with and you want to try to find someone, either let me know or just blast out an email to the class, and feel free to do that. I don't think it'll be a particularly challenging lab, but there are a few things that may, if you haven't done them before, may throw you off. What is the lab then? Well, this is going to be a lab where we're going to read from a file, and we're going to create a very simple program to filter through the contents. I'll just show you the program quick, and let's see. What did I do wrong here? Oops. I need to recompile it, so just give me 1 second here. All right, so here's the program, and what we're doing is we're going to create this menu system, and this allows this program to run until I want to quit. So you can see here that it cleared the screen, and then it presented me with 5 menu options. First 3 are just listing contents of this file that we're reading from. The 4th is going to allow us the capability to write to the file, and then the 5th will just allow us to quit. So obviously if I choose menu option 5, we quit, we cleared the screen, and I have my program print off a little end of run. If I run that program again, and we list or choose option 1, you'll see that what I did is I printed off, and I'll go through the format of this in just a second. We printed off these high severity vulnerabilities, okay, and then this is the format pulled right out of that data file. 2, okay, same thing, and then 3, same thing, just low, okay, so just low, medium, and high. If I choose option 4, that gives me the ability to enter in data, so I'll call this one Josh test. The severity will be high, the date doesn't matter, and the vulnerable program, I'll just say it's Firefox. Okay, so I enter that in, and now, because I set that as a high vulnerability, if I choose menu option 1, I should see there's the CVE, or the vulnerability that I just entered. All right, so that's the program. And what this is all telling you to do is just exactly that. I've given you a copy of that compiled program. I did compile that with GCC, so that should run in the IA lab, so you can see the behavior of it. I don't want the program to quit unless you select quit from the menu option. I do want to see, when I look at your source code, I want to see a structure to read and write the data from and to the file, and we'll go through some samples of that here in just a little bit. And the program needs the ability to both read and write to the same file. Okay, you notice that when I ran that program, that I wrote to that file, I wrote to the same file that I was reading from. So if I go back in here and list all the high vulnerabilities again, that that addition, that entry that I created is still there. It persisted to the file, and it's in the same file that I'm reading all this other stuff from. Look at the demo program, and then here are some hints. So just go through those and just keep those in mind as you're going through the program. If you want an additional challenge, then I would say add a create additional menu item and actually be able to search through the file itself. So instead of just listing all low, medium, and high, maybe I want to search for programs. I want to be able to search for Firefox, and so that would be a sixth menu option that you could create that would maybe make this a little more challenging. As far as the lab, then, so if we look at the structure of that data that I'm querying, okay, and this is I provided this in the Dropbox. You can see that we'll get into file structure here in just a little bit, or file formats here in a little bit. But this is all just space separated. Okay, so how we create files is going to be typically by record, and then so by row, and then the number of rows. And so here we have, if we could see those characters, there's a line carriage, line feed, carriage return that gives us a new line. And so we read this record by record. And then how we split up each record will depend on what we want to split it on. Okay, in this case, I'm just doing a space, and you'll see that as we look through the code, how we can query the database off of being separated by a space. A very common format would be CSV, or comma separated values. You can have tab separated. You can do a variety of things. So for this file, though, we're just using the space. Here's the CVEs. So you can have CVE 2014 240 2040. Okay, that's one. Here's the severity, so that's the second column of data. This is the date, and then this is the vulnerable program. Okay, so you can see here, here's one for Mac OS X, here's a couple for Wireshark, here's one for the Linux kernel, F460, I have no idea what that is, GNU TLS. Okay, so that's what these are for. Before I go into the program then, I just want to back up 1 second here, and we'll look at CVEs. So what is a CVE? A CVE is a common vulnerabilities and exposures. You can see I use Google to search for that. The reason I'm using that in this lab is just because it's something that you'll become very familiar with as you progress along in your security career, if you aren't already. And so instead of just making you create a program that searches trivial things, at least here you're getting some exposure to those topics that you'll be using later on in your career. If we look at a CVE then, you go to cve.miter.org, and it's just information about a vulnerability in some software, some application. And what these become, they're the notification for the industry from system administrators and programmers and whoever else is maintaining all these systems. It's a notification to say, hey, here's a vulnerability in, okay, and if we go back to our code here, you can see here's a vulnerability in Wireshark, and you need to be aware of it. Here's a vulnerability in Mac OS X, and usually after these CVEs have been issued, then Mac or the company that is responsible for the development of that product releases the fix for it. And so that's how it's one way that we keep track of these vulnerabilities. It's also when you're on the offensive side, maybe you're a pen tester or vulnerability assessment. It's how you look for vulnerabilities. You say you can query a server. Maybe it's running an old version of Apache, and you can say, okay, I've identified these guys running Apache, whatever an old version is, 1 point something. And I can now search this database to find all these vulnerabilities that are out there based off of that old version of Apache or whatever software you want to look at. And now you can identify potential exploits in order to penetrate the system, or leverage that vulnerability to gain access. As far as this, let's see. So if we want to just search CVEs here on the left, you can see we can search CV search the master copy. And if I wanted to look for anything with MySQL, so MySQL is a very popular open source database. Here you can see a whole bunch of vulnerabilities, CVE 2014-2451. If we click on that, then we get more information. So just a basic introduction to that. You don't need to know too much about them other than, really all you need for this lab is to understand the structure of this program. And really, of that, you really only need, this file, and really of that, you only need to know the high and the medium and the low. So that's our CVEs. The program itself, then, I did one step beyond what I normally provide students, just because it's an online program, and I provided you with the cmenu.c file. And so this you can use as a template to build your program. It doesn't have everything. There's none of the file reading and writing, so that's the main focus of this lab, is to read and write to the file. But because I use this menu, and while a lot of our 150 sections use that, not everybody does. And so I didn't want you to have to struggle with creating this menu. I went ahead and provide you an example of it here. So just to run through that real quick, how that menu works, what you were seeing in my sample program was just a while loop. While my menu choice is not equal to 5, this is not a comprehensive menu. If you type in a character, your system will blow up. You just need to Control-C, kill it, and run it again. There's things we could talk about how to fix that if you really want. Just let me know. But it's not important because this isn't something that we're going to release to the masses and let them use. So we just need something simple, and this is what this is. So well, first I have a function print menu, and you can see that print menu returns an integer. And if we go and scroll down to print menu, you'll see that I'm printing my menu here. I'm capturing the menu choice using a scanf, and then I return that menu choice. So I do this outside of the loop, so that way if for some reason the user runs it, wants to quit right away, then I don't even enter and the program just terminates. Otherwise, I compare. I say, while menu choice is not equal to 5, and again, you could make that more robust because I only have 5 valid menu options, 4 of them which I want to enter into this loop. But as long as it's not 5, we want to enter into this program. I call system.clear. So this is a function that you can use, the system function. It expects as one argument a string value that it will try to execute basically at the command line. Okay, so clear is what we'd issue at the command line to clear the screen. So you can use that here if you want. Keep in mind that this does reduce portability, because if you wanted to run this on a Windows machine, this wouldn't work because this isn't how you clear the terminal on the Windows machine. You have to use CLS. So just something to keep in mind, but I will be running this on Linux, so don't worry about that unless you want to. We have a menu choice, so we have to determine what menu choice they did and then perform the appropriate action. So I use a switch. Okay, so here's our switch with our menu choice that we selected, or that the user selected. We stored that value in that variable, and now I have simple cases. Case 1, high severity. Case 2, medium severity. And case 3, low severity. Okay, so it's up to you now in your program to open the file, and we'll talk through all of this here in just a little bit, but open the file, read the contents, and then print out the appropriate records. Case 4, it's going to be right to the file, and then we have our default case, which is just you didn't select a valid menu option. Okay. At the end of the loop, we have to prompt the user to enter a menu item. Okay, because once we get to this point in our program execution, we're done. We did what the user asked us to do, so we need to print the menu, prompt them again, and that's what we're doing here. Once we break that while loop, then we can clear the screen and print off that we're done running. Okay, so how does that program look? Let's see. Okay, so there's high, there's medium, and there's low. So it looks a lot like the program, the sample compiled program that I provided you, just that it doesn't have the functionality that you need to develop. But it's all there. That's the stub of it. Okay, so again, I just wanted to provide that to you so that you didn't have to spend a lot of time, if you haven't done menus before, spinning your wheels. Again, and if you go to the book and look around page, let me see if I can find it again, 428 or so, that's another example of how to do that. All right, so that's the lab. And moving into the content then, our lecture here. So we'll talk about reading and writing for files. It looks like a lot of slides here, but we're going to move them through them pretty quickly. So C file processing. Okay, up until now, all of our programs, once we've ran them, they've stored data, they've stored values in memory. So as soon as we terminated the program, anything we put into the program was gone. It was left in memory. Okay, we deallocated the memory, and we don't use it anymore. So that is of limited use most of the time. So most of the times when we run a program, we want to be able to either load data that's been stored somewhere permanently, or modify that and also create new and push it back and store it permanently. So how do we do that? Well, we do that with files. And what files are the building block for data storage. There are some very common file formats, and if you're going to go into a lot of web development, you'll see if this works, XML and JSON. You'll see CSV quite a bit, and that's just in general programming applications. You might see text, and you might even see binary. Files, at the very core of a file, it's a binary file. We just use those ASCII characters in order to be able to see the content itself. Databases. Okay, we store a lot of information in databases. A lot of systems are run because of databases, and databases are just files in a file system. How those files are structured and organized and searched makes a big difference, but they're just files nonetheless. As far as files in C, C imposes no file structures. Okay, we're going to talk about a little bit that when we open up a file in our C program, it's just a stream of bytes. So C doesn't know if it's a CSV, if it's a CSV, if it's a JSON, if it's text, whatever. It doesn't impose any structure or restrictions on it. That's left up to us to do. So keep that in mind, that when it opens a stream, it doesn't matter. It doesn't even matter the file extension. So when we look at some of that sample data, the file I provided for the lab is a .dat, and that really doesn't mean anything because C doesn't care. C just needs to find a file that it'll open up a stream to. When reading a file, we delimit it, and the order of columns is very important. So how we delimit the file, spaces, tabs, commas, whatever, and then the order that we do it in will be critical in how we read the program, because we're going to create a program and it's going to expect that the structure of our file is maybe first name, last name, social security, and email address, and it has to be in that order because that's how we're going to treat that data that we read from the file. So how we delimit it and then how we read it, the structure of that file will be important for us, but that's something that we have to maintain and manage. When it comes to file operations, there's really two things we're going to do: reading and writing. Today we'll talk about reading. Next lecture we'll talk about writing. So for reading, we're going to be finding, opening, reading the contents, writing, creating, updating, deleting, and possibly overwriting. As far as just some terminology then, is a record. What do we mean by a record? Well, a record is composed of several fields. Usually a record is going to live on one line, and a record represents a single instance of something: an employee, a user, a student, a tweet. And so when we look at files, then we structure those records in a way that makes sense. Usually a record has some sort of relationship. Okay, an employee, a user, a student, this all has a relationship. And then these records become really ideal for creating structures that represent those records. And that's why, in fact, that I talk about file I/O after we talk about structures. Files themselves then can contain a single record to millions of records. It really is. I've worked with files myself that have contained millions of records. I've worked with systems that have files that contain very few records, 1 or 2 records possibly, but then they have millions of files across the system. So it's really, again, really it just depends on how the system, how it's architected. As far as large record sets, okay, there's a whole area of managing this data and these large files that we're not going to get into, and it kind of touches on relational database ideas, and that is that we typically would have a record key. We'd have something in there that uniquely identifies a record in a file. We might organize or sort a file in a specific way, but we're not going to talk about that. So just keep in mind that we're just looking at very simple sequential data. We're just going to read to it and write from it, but we're not going to apply a lot of optimization on those files or that data itself. So what is a file then? Well, it's just simply something that's going to contain a series of records. Those records are typically going to be in sequential order, and we're going to create a stream in order to read and write from that file. Okay, so again, C doesn't really care the structure of it. It's just going to see, when we open a file, it's just going to see it as a sequential stream of bytes. Okay, we'll open that stream, we'll open that file in our program, and we'll get a stream of bytes. And then we'll read through that stream of bytes, and that stream will have an EOF marker. Okay, so EOF stands for end of file, or sometimes a specific byte number. But for us, it's just going to be an end of file. So you'll see in our code that we're going to loop over that stream until we get to the EOF, or the end of the file. So what happens? Okay, again, we open the file, we associate a stream with it, and now we can interact with or read from that file. Something that we've been using here up until this point, we haven't really talked about, is standard in, standard out. Okay, those are actual streams. They're just streams that the program creates. It's a connection between the program and the underlying operating system that we can send data, send information to, and read it back from. So when we used fgets, we use standard in. Well, these are 3 streams that are auto-opened on program execution: standard in, standard out, and standard error. So that's why we had that's how we got standard in. That's how we got the stdin when we used our fgets for our 3rd argument. We also have standard error, but we don't use that, so we don't have to worry about that one for right now. So what does a stream do? Keep in mind, it provides a communication channel between files and programs. What do we do then when we open a file? Well, it returns a pointer to a file structure Okay, keyword here being a pointer, and then we'll have a new file structure type that we'll look at, and that tells the system how to access the file. Okay, so we're not really going to get into the nitty-gritty of that file structure, but we are going to have a file pointer, and we'll use that file pointer to open files and then read the contents from it. So just again, keep in mind, when we open a file, we get a stream associated with it, and that's just a sequential stream of bytes. All right, here are our new input-output functions. So think about this in order, because I list these functions out in order in the way that we're going to interact with files. First of all, we need a pointer to a file. Okay, you see that in code. Then we need to open it, we need to read it, we need to check, we need to read it until we find the end of the file, and then once we're done, we need to close it. Okay, so we have fopen, that'll help us do that, that'll open the file. We have fscanf, that's how we're going to read the content, and you'll see here that scanf, fscanf is very similar to scanf. We have a function to test for the end of file, and there are some caveats with this, and I'll go through a couple of different scenarios here where we can use, maybe not even have to use EUF here in our programs, and then fclose, and fclose just closes the file. When opening a file, this is important to know that you open it in different modes. Okay, so when we go to open a file, when we go to create that stream, we have read-only, we have create a file for writing, append, read and append, create a file for update if it exists, discard the current content. So there's all these different modes, and there's more than this, and I'll show you in the next slide a better list of these modes. But my view, my philosophy on when opening when opening files is I open it in the most restrictive way that I need in order for my program to run. At this point in time, we're going to look at a program that just reads from a file, and if my program only needs to read from a file, then I'm going to open it up in read-only mode, because I don't want to take the chance that something could happen, or maybe another programmer comes down the road and implements functionality that he shouldn't have, that allows for me to write to the file or overwrite a file. You know, so these modes become very critical, that when you open up a file stream, you understand what mode you're opening in and what that mode does. Okay, we're going to talk through the functions real quick. I'm going to provide you can see here, there's our screen captures for the function definitions, the function prototypes. First one is fopen. Okay, we can see the return type here is a file pointer. Okay, so that's the syntax for a file pointer. Remember, it's important to be able to take a look at something like this and understand what the function is doing, what it returns, and what it expects before you go ahead and try to use the function in your code. So, returns a file pointer. We have two arguments, constant char pointer file name and constant char pointer mode. So what does this mean? Well, constant is just that keyword that says that this function will not change these values. Okay, so that's like setting them to read only. Char pointer, okay, we know that's a string, and then we know the name of that char pointer's file name. So this is a string, it'll be read only, and same with this, constant char pointer mode. Okay, so it's a string that's read only. Here you can see the two arguments defined, file name. Okay, so where is the file located? What do you want to open? And mode, what mode is it going to be in? What does this return? Oh, and here's some of those modes that I was talking about. And then what does it return? It returns a file pointer. Otherwise, null is returned, and don't worry about that part. Null is returned if it was not able to open it. Okay, so that'll be important, just like malloc. Our program really can't proceed if we don't open the file that we're looking for. And so we'll add in a little bit of logic to say, if I can't find the file, if the file pointer is null, then stop the program. All right, here's fscanf, and this looks like a lot, but it really is actually pretty simple. What does fscanf do? Well, it's just like scanf. Okay, if you go and look at the definition for scanf, you'll see that this is exactly the same. The only addition is this first argument is now our file pointer. Okay, so once we've created that file pointer, we've opened that stream using fopen, then we can use fscanf to read the contents of the file using that file pointer. The second argument will just be our format specifiers, and then the additional arguments will be where do we want to read those values into. So just like we use scanf to read a value from the command line, from standard in is to stream, and store it into a variable, we can use fscanf to, instead of reading from the standard in stream, we read it from the file stream that we've opened and store them into variables. Okay, so you'll see that it's very similar. Here's some format specifiers and some other things just to look at. Also keep in mind that fscanf as well as scanf, its return type is int, and so it returns an integer value based off of the number of records that it matched based off of your format specifiers. So if that doesn't make any sense, we'll look at it here maybe in a little bit. FUF, okay, return type is integer. It has one argument, that's a file stream. Test the end of file indicator for the given stream. Okay, so all we're doing in this function is we're looking for the end of file indicator in that stream, in that file stream. You'll see here in the code sample that we use that in our while loop as our condition to break the loop. Once we've reached the end of file, break the loop, we're done reading the contents and move on. Fclose, okay, so obviously after we've opened a stream, we want to close the stream, much like malloc. Once we malloc memory, we want to deallocate memory. Fclose, one argument, and it's again that file stream, that file pointer. Once you've read a file, okay, it's a sequential stream of bytes. So once you've started reading that sequential stream of bytes, you have a pointer and you're going to point through that stream. Once you get to the end of file, once you've found that EOF marker, then your pointer is pointing at the end of the stream. And if you want to continue to read it, if you want to read it again, you have to rewind it. You have to take that pointer and say, yep, pointer, I need you to go back to the very beginning of the file stream. So that's what rewind does. Another function, same argument. It's got that file pointer that we're going to see, we're going to create, and it rewinds it. Okay, so I'll show you an example of what happens if we try to read from a stream when you're already at the end of the file. It doesn't blow up your program. It's not an error. It's just that it doesn't have anything to read. So your condition will be true right away when you're testing for that end of file. Okay, so we're going to look at a program very similar to this, and then here's the practice. And I have that uploaded as a separate lab document. If you want to work on it, you need the extra practice, do this, send me your code, and I'll be more than happy to take a look at it. All right, that's it for our slides. Okay, before we get into this program, and I'm going to upload it, it'll be file.io.c. We'll also have students.dat. Okay, and you can see here that here's a file. It has 3 records, 1, 2, 3. Each record is on its own line, and this is a very simple space-separated file format. Okay, so I have one piece of data here, name. Second is going to be your program of study, and the third will be your student ID. Now, it's space-separated. So if I wanted to take CyberOps and make a space, now that would change the way my program reads, because it would look at this as 4 pieces of data instead of just 3. Okay, so that's why everything is kind of lumped together there, because I'm using spaces to separate. Also keep in mind here, I have this extra line, and this is part of the problem that you'll run into when we use the EUF, that EUF function, FEUF function. Okay, so just keep that in mind. So you'll have this, I'll upload this into the content section as well. Here's our file, and you can see here that that's really, take out all my comments, all that commented code. It's a pretty small file. Here we have our includes. Okay, so standard IO, everything that we're talking about is coming from this header file, standard IO, standard lib, and string.h. All right, I said earlier that structs become a great way to represent those records, and this is very true here. So I create a struct student. I said that this data file is going to represent students, and so I create a struct that represents that data. You can see here that I have a string for the name, a string for the major, and an integer for the student ID. Okay, same thing here. Matches it up. Name, major, student ID. And that's the structure. That's what I'm going to use in my program to store that data into. Now, when we get into main, I'll run this program first. You can see what it does. IO.c. And that's it. Okay, so this program is going to print this header row. That's just so I know what I'm looking at, and that's going to print each record in that file. Okay, that's all it's going to do. Very simple. Read it and print it. So if we get into main, this is how we declare a file pointer. Okay, we used all uppercase file and then our asterisk for a pointer. Okay, and now we have a file pointer. So I declare that pointer, I set it equal to null. I then declare a struct variable, because I'm going to use that variable, that structure, to read the contents out of the file, store it in the members of that structure, and then later on print it off. Once we've created that file pointer, very first thing we want to do, and this makes sense in a logical fashion, is we want to open it. So we use fopen. And you can see here that we're doing an assignment operation, and then we're comparing it to get that true or false that we're looking for. So fopen, we knew from looking at that prototype that fopen has two arguments, two string values, students.dat, that's the name of the file, and the read mode. Okay, so read only. So we're running this program. Keep in mind, this is where the file is located relative to where we're running the program. So just make sure that for now, unless you want to put in full pass here, there's this thing called absolute and relative pass. And you don't need to worry about it unless you want to. But it just needs to be this file, this data file needs to be in the same directory that you're running this program in. As long as you have it there, you'll be good to go. So we try to open that file. The contents, remember this returns a file pointer. So we assign that to CF pointer. And then after that, we compare the value of CF pointer to null. If it's equal to null, then we print file not found. So what's a different way of doing that? Well, we could do it like this. Okay, just get rid of those brackets, and then I could compare CF pointer to null. Okay, this would be, oh, I didn't do that one. This would be the same thing. Okay, so that's just a shorthand way to condense our code a little bit. Okay, so fopen, we return the results of fopen, assign it to our CF pointer, that was our file pointer, and then compare the value of the pointer. If it's equal to null, we need to stop. We weren't able to open the file, we don't have a stream. If it's not equal to null, we got it, then we'll go down the else branch. So this is the two branches of logic, the two main branches of logic in this program, whether or not we should proceed or not. Okay, I'm just gonna go back to here. Return, okay, we're in main. Main is return type is an integer, so you can just return. You could return 0. Could return -1. It doesn't matter. The point is that you want to stop your program before you go. Return 0 means the program worked normally and exited normally. Return -1 means something happened and it terminated or ended, didn't run, it ran abnormally. In this case, I would say that it's abnormal. You know, we expect to find this file in order for this program to run. But what you do with that return type, I don't know. So don't worry about it. Again, the point is that it just stopped. We just stopped execution here. So we just want to return. And you don't even have to have a return in here. Okay, because we have this if-else branch. If we went down the if branch, we're not going to go down the else branch. And if you look at my code here, there's nothing else. So it would have returned anyway. So the program's fine. Okay, well, if we have a pointer and its value is not equal to null, then we can go down the else branch. And we're going to do just a couple of things in here. You can see this is all the code. With all my comments. If I clean up all those commented out code, would be even better. First thing we're going to do is I'm just going to print that header. Okay, so that very first row from our output, name, major, student ID, that doesn't come from the file. That comes from my program, and I'm doing that right here. Okay, if you see this syntax here, so the percent, and then a dash and a number, and then the rest of the format specifier, this is just adding some padding. So if you look at that output again, you can see that everything is pretty much, it's nicely aligned. Well, it's because of that padding. And you'll also notice that it's left aligned. And that's what adding that dash does. If I just did 10, it would pad it with 10 character spacing, but everything would be right aligned. So that just provides it, again, just provides it to the left. And then I print a new line. And then those are the values that I print. I printed that header, and yeah, you need it, you don't need it, doesn't matter. The first thing I want to do, okay, we have an open file stream. We have a file pointer that's pointing to that stream. The first thing I want to do is use fscanf to read the contents from that file. fscanf is going to read it one record at a time. Okay, so we're going to use it, we're going to treat it just like scanf for the most part, except the first argument is our pointer. Okay, fscanf has to know what we're reading from. What stream do you want it to read from? So this is the file pointer that we just opened. We use then format specifiers, just like we do with scanf. What type of data are we expecting to read from that file? So %s, %s, %d. So string, string, and a digit. And if we go back and look at the file, that makes sense. We'll treat that as a string, that is a string, and that as a numeric value. Okay, so that's what we're expecting to read out of that file. And then just like scanf, where do I want to store that information? Well, in this program, I created a variable called a student. A student is a structure. If we go back and take a look at that structure, you'll see we have 3 members, name, major, and student ID. Okay, these 2 guys are char arrays, and this is just a simple integer. So going back to fscanf, because that is not a pointer, that structure variable is not a pointer. We use the dot notation, and we have name, major, and address operator dot student ID. Okay, so we treat them just like this just becomes a lot like a scanf call. Okay. Now we enter into our while loop, and this is where we are going to process the results of reading that file. So the first thing we do, okay, you can see there's this kind of we read that stream, and if we read in the end of file, then this test would fail. We wouldn't enter in the loop, our program would be done. In this case, we haven't read the end of file, so we'll enter into this loop. So we test for the end of file. Is our CF pointer currently pointing to the end of the file? Okay, we use the exclamation, logical negation. Okay, I'm assuming that you talked about that in 150, but it just reverses the meaning. So if something was true, it's false. If it's false, it's true. What we're saying here then is FEOF, when it finds the end of the file, it returns true. But we don't want to, we want to iterate until we find the end of the file. So as long as we're not at the end of the file, we want to go into this loop. So we negate that. Then we come into the file, we use printf. Okay, that's nothing new there. So printf with our using that structure variable that we've stored data into its members, and now we read the next line. Okay, so we just take exactly what we did here on line 32 and we'll repeat it at the end of the loop. Loops around, we check, are we at the end of the file? If not, go ahead and print again. Once we're all done, then we use fclose and our file pointer, and that closes the string. Okay, there are some issues with this. And if we go back to the run, we saw that this ran fine. We had 3 records printed. If we go back to student.dat, 3 records are printed. If we remove that new line and run that program again, it only prints 2. Okay, so there are some issues with how this function is structured, or how this code is structured. And this pretty much comes right out of the book. Okay, so if you're having some trouble following this, or you want a slightly different version of it, or even a different explanation, the author in the book uses a very simple format, a very similar format to this. So I like to structure how I read these a little bit differently. Okay, so the first thing I'm going to do is I'm going to comment that code out. I'm going to comment out this while loop, but not this, and then we'll comment that out. All right, so what are the changes? Well, I'm going to use the fscanf inside of the loop itself. So instead of reading from it and then using FEOF to test for that end of file, I'm going to use it inside the loop. So that means that outside of the loop, I don't need to do this anymore. Inside the loop, because I'm reading from the pointer and populating these members inside this loop, inside the condition of the loop, I don't have to do it in here as well. So I can get rid of this line. All I need to do is print. Okay, you can see here that I'm comparing. Remember when we looked at that definition of fscanf, it has a return type of integer. So what we're saying, what fscanf will do, when it doesn't match any contents in the file, when it reads from that stream, reads from this stream, looking for this formatted data, and it doesn't read anything, it returns -1. -1 is the end of file marker. And this EOF is a symbolic constant for -1. Okay, so if you printed off the value of that as a numeric, you'd see it just prints off -1. So I can now take this condition and say that while fscanf does not return -1, that means it read a record in that file stream, and I can enter into this loop and print it off. Okay, so with those changes in place, recompile it, rerun it, and you see all 3 records are printed. I don't have to have that extra empty new line in my code, and it works just fine. Okay, so there's the changes. And let me just get rid of all of this then, just to condense it up a little bit. When I upload this code, I'll leave all the code in there that's commented so that you can see the 2 different versions that we looked at. So you can see how that FEOF function works. But this is the way that I'll typically do it. So again, just to recap here, we print the header, and then we use fscanf. First argument is that file pointer. This is the type of data that we're expecting to read out of it. Here is the variable list of arguments to store that data into. And then we compare the return value from our fscanf function call to end of EUF, end of file. Okay, symbolic constant represents -1. As long as it doesn't return -1, we're good to go. We've read a record. We can do something to that record, because then we'll iterate in the loop, and then we'll come back and we'll try it again. Okay, as soon as we reach the end of the file, fscanf returns -1, and we're done. We can break the loop and move on. Here's our fclose, and we'll close the file. Okay, so I told you that we may need to use rewind. Fclose, okay, don't close the pointer until you're done working with the file. If you close it and then you try to iterate over it again, you'll get an error. So just make sure that it's just like malloc. We don't free memory until we're absolutely sure we're done with it. Same with file pointers. We don't close them until we know we're done with them. But let's say that I wanted to iterate over the contents of that file twice. Okay, so I just repeat that. Here's that loop. I just repeat it. So if this works, what I should see then in my program is the same 3 lines printed twice. So we'll recompile it. You'll see there's no errors there, errors or warnings. Run the program, and we didn't. We just got the one iteration. So what happened? Well, we have a file stream, CF pointer. By the time we reach the end of this loop, we reach the end of that stream. So our condition is telling us that our pointer is at the end of the file, EUF. So if we go to this loop and we run fscanf again, well, it's just going to tell us that, that we're at the end of the file. So we're not going to enter that loop. Well, the condition is not true, so we'll close the file and terminate our program. In order to iterate through that stream again, we got to call the rewind function. So we call rewind with our pointer. Okay. Now when this is done, stream's at the end of the file, we rewind it back to the beginning of the file. Our file pointer is pointing at the very beginning of that stream, and we can iterate over it again until we reach the end of the file. So now we'll compile the code, run it, and you'll see we got the same 3 records printed twice, which is what we were expecting to see. So that's how you use rewind. In the lab, you're going to need to use rewind because after you read through the stream, then after you've read through it, you're going to be at the end of the stream. So you need to make sure that you put that file pointer back to the very beginning. All right, I think that wraps it up. Again, take a look at the code, take a look at the samples in the book. Let me know if you have questions. This will be enough to get you started on Lab 7. And then for the next lecture, we'll talk about writing to a file. All right, thanks.